My name is Jun. I am CEO and co-founder of FuriosaAI. FuriosaAI is building a silicon chip for AI, especially with a strong focus on this inferencing in the data center infrastructure. So AI is a very consequential technology. It's about to become far more pervasive than it's today, embedded everywhere in everything. We are right now talking about agents are eating the world. We are witnessing a new era of very powerful AI applications powered by frontier models like GPT, like Llama and DeepSeek, who can do even reasoning these days. So these rapidly evolving applications are driving an unprecedented demand for compute, especially for inference. Just recently, Sam Altman kind of tweeted that their GPUs are melting from the load of generating the Kibini-style images. Just those simple applications put so much pressure on their infrastructure. But now, imagine the scale of compute we will need going forward. So here, the question is our infrastructure ready? The energy consumption in data centers are really spiking right now. These days, right now, we are talking about gigawatt scale data centers. Gigawatt actually means you need like one nuclear power plant. And right now, we are talking about building like 20, 30, even more gigawatt scale data centers globally. So this energy cost is actually fundamental cost of running AI. A lot of AI companies are actually losing basically money due to this infrastructure cost. So our mission is very clear. Our mission is to make AI computing sustainable. And by sustainable, we mean not only we don't mean just the environmental sustainability, we also mean the business sustainability. As I mentioned, the cost of AI is highly related to energy cost. And if you basically don't make money out of doing this AI service, the business model is not basically sustainable. So just the world now must shift from the gasoline to electric vehicle. We need the same kind of transformation in AI computing toward a more sustainable and energy efficient future. So quite similar to the shift from gasoline car to electric car with a new leap in technology, and very similar to the evolution from the CPU to the CPU. We need a breakthrough product and a fundamentally new approach in AI computing. Very first principle approach to tackle this vision. So here comes our Renegade, our second-gen product. I brought the real chip here. Actually, we launched this product actually last year. If you look at the AI chip, there are three important specs. Probably you remember. One is what is the compute performance. We are delivering 512 teraflops of performance. And what is the second thing is your memory performance. Right now we are capable of loading data at like 1.5 terabyte per second. Also, the third important spec is then what's your energy to deliver this total horsepower actually. So right now this chip is consuming 180 watt, under 200 compared to our competing GPU product, which is usually consuming over 300 watt. Actually, if you save just 1 watt, it translates to $20 saving per year. So if you save 100 watt, you can save $2,000 per year. If you operate this chip for, let's say, 5 years, it translates, just single chip can save you $10,000 per year. And also imagine that you are deploying tons of these chips through your data center. Actually, this is a huge kind of cost saving as well. To enable this frontier kind of product, we are definitely working with world-class partners. Right now, this chip is fabricated on TSMC using 5-nanometer technology. And this chip is almost packing 40 billion transistors inside. We are also working with SK Hynix to use the latest, one of the most advanced DRAM technology, and we are using also the most advanced packaging technology as well to deliver this product. But the most important thing, the core technology, is like not only is the spec, but like how we make this achieve this energy efficiency. This is all comes from our fundamental innovation in our chip architecture and our software stack on top of it. So we call our chip architecture as a tensor contraction processor. It's quite a jargon, but I can say the tensor, in simply speaking, here tensor contraction, and the tensor means like a multi-dimensional, large-scale matrix multiplication kind. It means tensor contraction means those large-scale matrix multiplication. So our processor is quite designed to run this large-scale tensor as fast as possible, and at the same time as an energy-efficient way as possible. And the challenge of AI chip design also is that AI workloads are quickly changing. It's not like a mining algorithm. Mining algorithm is just fixed, right? You can just optimize for fixed algorithm. But AI workloads are advancing so quickly, so your design should have some flexibility, good enough flexibility to accommodate all the changes happening on like an AI innovation. So our innovation focuses that we achieve a good sweet spot of being generalized for many tensor-based workload, yet specialized enough to exploit many parallelism in AI accelerations. So you can read our technical paper if you are more interested. So what's our benchmark? So there is a very kind of golden kind of a metric to measure the efficiency and performance of AI model these days, which is actually tokens per second per watt. When you measure our token per second per watt against kind of competing GPU products, our benchmarking already demonstrate we achieve almost 190% greater efficiency compared to GPU. It's why now we are sampling with many quite good customers already globally. There are many enterprises looking for alternative to the current GPU products, and it's why they are right now testing our chip and thinking about adopting our chip for their future inference platforms. So I'd like to briefly also introduce our company. We started as a startup company 8 years ago with the 3 co-founders, including me. My career was all about the semiconductor and the electrical engineering. And when we started in 2017, we actually had a high kind of belief about the future of AI. It is a very transformative technology. And from the very beginning, we set out to build high-performance, energy-efficient inference chip natively designed for AI at scale. And after our first flagship product, actually we decided take a very bold bet, designing a large-scale SoC for massive language models, even though at that time the language models were still quite experimental at the time. So it was quite a risky move for a startup, but we believed in the future this model would bring to the world actually, because we still have the same belief that the more capable AI will bring the more value to the people, and to realize the future, we definitely need quite sustainable AI infrastructure as well. So I hope, if anyone who need a strong, efficient AI compute solution, whether in cloud, and especially also if you like to own your own, on-premise, your own AI computing infrastructure, we hope we can work with your team, and we are very committed to support that, building this new AI infrastructure together with you guys as well. So thank you very much.